Good evening, everyone. I request Rutanshi ma'am to start the session. Rutanshi ma'am, hello. Rutanshi ma'am, please
Hello.
start the session.
Uh, Good afternoon, sir. Good afternoon, all the participants, and a very warm welcome to respected Dr. Paresh Patel, sir, beloved lecturers, Dr. Khushbu Desai, madam, and dear students. I, Rutanshi Patel, once again welcome you all for our next exciting session on the topic Symmetry and Group Theory and its application in chemistry. It's our privilege that Dr. Paresh Patel, sir, is again joining us for today's webinar. In the last lecture, he has given excellent subjective knowledge on the topic. Sir, everyone learned a lot and benefited very much from your lecture. Thank you so much, sir. Now, I would like to request Dr. Paresh Patel, sir, to continue with the session. Over to you, Paresh, sir.
Thank you, Kusuma Madam and Pranse Madam, for giving me opportunity to share my views to the students. So, dear students, in the previous lecture, we discussed about the general introductory part of the molecular symmetry and group theory. Today, we are going for the matrix portion. So, let us start with the definition of the matrix. Matrix is a combination of the numbers arranged in a rectangle array. Combination combines with the another matrix in following definite way. So anyhow, matrix can be represented as a combination of the numbers arranged in a rectangle array. As for example, matrix A can be represented as A11, A12, A13, and so on A1n. Similarly, A21, A22, A23, and so on A1, A2, and similarly AM1, AM2, AM3, and so on AMN. Okay, this is the first element of the matrix that can be represented as A11. It means first element of the first row and first column. This can be represented as a row and this can be represented as a column. So this is the element of the first row and first column. So anyhow, matrix can be defined as rectangle array of the numbers, or we can say arrangement of the rectangle arrangement of the numbers in numbers of the rows and numbers of the column. Okay, this is first row, this is second row, and so on. This is the nth row. Similarly, this is the first column, second column, third column, and nth column. So anyhow, matrix can be represented as numbers of the rows and number of the column. So dimension of the matrix can be represented as number of the rows and numbers of the column, numbers of the columns. As for example, matrix A is equal to 1, 2, 2, 1. This matrix can be represented as number of the rows is equal to 2, number of the row column also 2. So this can be represented as a 2 by 2 matrix. B is equal to okay, here numbers of the rows is equal to 3 and numbers of the columns can be represented as 2. So this matrix can be represented as 3 by 2 matrix. Okay, so dimension of the matrix can be represented as numbers of the rows and numbers of the columns. Now next step is the summation and subtraction. Summation and subtraction of any two matrices is possible if dimension of both the matrices are the same. then and then summation and subtractions can be possible. As for example, A is equal to 4, 5, 6, 7, 3, 1. B is equal to 1, 2, 1, 3, 1, 0. Now, in both these cases, both these matrices, the dimension of the matrices are the same. This is 2 by 3 matrix. This is also 2 by 3 matrix. So if you go for the summation, A plus B is equal to 4 plus 1, first element of the first row and first column of the first matrix, and first element and the first element of the first row and first column of the second matrix. Similarly, 5 plus 2, 6 plus 1, 7 plus 3, 3 plus 1, 1 plus 0. So resultant matrix is 5, 7, 7, 10, 4, and 1. So this is the resulting matrix if we go for the summation. If we go for the summation, subtraction of two matrices, suppose A minus B, then what will happen? 4 minus 1, 5 minus 2, 6 minus 1, 7 minus 3, 3 minus 1, 1 minus 0. So to give 3, 3, 5, 4, 2, 1. So this is the A minus B, or we can say this is the subtraction of any two matrices. Next one is combination or multiplication. Combination or summation or multiplication of any two matrices is possible if the number of the rows of the first matrix is equal to number of the column of the second matrix, then and then combination or multiplication is possible. As for example, A is equal to 2, 1, 3, 2, 1, 0. B is equal to 2, 1, 0, 3, 2, 1. Okay, combination or multiplication of any two matrices is possible if the number of the rows of the first matrix is equal to number of the column of the second matrix, then and then combinations or multiplication is possible. So we have to go for this one. First row, first column, second row, second column. So if you go for the A cross B is equal to first row, first column, it means 2 2s are plus 1 3s are. First row, second column, 2 1s are plus 2 1s are. First to second column, third column, 0 plus 1. Second row, first column, second row, 3 2s are plus 2 3s are. Second row, second column, it means 3 into 1 plus 2 2s are 2. Second row, third column, 0 plus 0. Now, third one, third row, first column is equal to 2 plus 0. Second row, second column, third row, second column, 1 into 1, 1 plus 0 is equal to 0. So, resultant matrix is 4 plus 3, 7, 2 plus 2, 4, 1, 6 plus 6, 12, 7, 0, 2, 1, 0. So this is the combination or multiplication of any two matrices. Next title is character or trace of matrices. This can be represented as chart. Now, combination or trace of matrix can be represented by symbol chart. And as for example, matrix A. This is 3 by 3 dimensional matrix. Now, character or trace of any matrix is equal to summation of the diagonal elements. This can be represented as diagonal position of this matrix. Okay, so here character of matrix A is equal to summation of diagonal elements. 3 plus 3 plus 4 is equal to 10. It means character or trace of this matrix is equal to 10. Types of matrix. Matrix can be classified as, first one is square matrix. Okay, if the number of the rows and number of the columns are equal, then that matrix can be represented as a square matrix. A is equal to 2, 1, 0, 3, 2, 1, 0, 1, 2. Now here, number of the rows is equal to 3, numbers of the column is equal to 3. It means number of the rows and columns are the same in this matrix. So this type of the matrix can be represented as a square matrix. Second one is diagonal matrix. Now what is diagonal matrix? We already discussed that this position can be represented as a diagonal position of this matrix. So the values of the diagonal elements have some definite values and remainings are 0. So this type of the matrix can be represented as a diagonal matrix. Third one is unit matrix. A is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. This is again diagonal position. The values of the diagonal positions are 1 and the values of other than diagonals elements are 0. So this type of the matrix can be represented as a unit matrix. Next one is row matrix. A is equal to, okay, if the number of the rows is equal to 1 and n numbers of the columns can be represented as a row matrix. Okay, here only one column and n numbers of the rows. If matrix consists numbers of the rows and only one column, that can be represented as a column matrix. Null matrix. null matrix or zero matrix. This can also be represented as a zero matrix. A is equal to 0, 0, 0, 0. Okay. Now the values of elements of the matrices are 0. This can be represented as a null matrix. And last one is singular matrix. Now what is singular matrix? Suppose A is equal to now if the determinant of this matrix is equal to 0, so that matrix can be represented as a singular matrix. In case of two-dimensional matrix, the determinant can be represented as summation or combination of diagonal elements minus other than diagonal elements. So 4 3s are 12 minus 2 6 are 12. So determinant of this matrix 12 is equal to 12 is equal to 0. It means if the determinant of this matrix is equal to 0, so that matrix can be represented as a singular matrix. Now, how to find out the determinant of this matrix? This is 2 by 2 matrix. It means numbers of the rows is equal to 2, numbers of the columns is equal to 2. Now, determinant of this matrix is equal to combination of diagonal elements minus combination of other than diagonal elements. 5 and 6 can be represented as a diagonal elements for this two-dimensional matrix. So 5 6 are 30 minus 3 2s are 6 is equal to 24. It means determinant of this matrix is equal to 24. Now, in case of the three-dimensional matrix, how to find out the determinant of this matrix? As for example, A is equal to 2 1 3, 1 2 0, 3 2 1. This is three-dimensional matrix. Okay. Now, determinant of this matrix is equal to 2 and remaining elements 2 0 2 1 minus 1. So remainings are 1 0 3 1 plus 3 1 2 3 2 is equal to 2 2 minus 0 minus 1 1 minus 0. Okay, this is two-dimensional matrix. It means combination of diagonal elements minus other than diagonal elements. Similarly over here, 1 minus 0 plus 3. Combination of diagonal elements minus other than diagonal elements is equal to 4 minus 1 plus 3 minus 4 is equal to 4 minus 1 minus 12 is equal to minus 9. So determinant of this matrix is equal to minus 9. So how to find out the determinant of this three-dimensional matrix? So first of all, we have to go for the first element of the first row, first column, then first column, first row, second column, and then go for the first row and third column of the element of this matrix. Okay, so this is the determinant of the matrix. Next table is the inverse of the matrix. Now, how to find out the inverse of the two-dimensional matrix and three-dimensional matrix. Both are the different. Okay, first of all, go for the how to find out the inverse for the two-dimensional matrix. Suppose A is equal to, if you go for the inverse of this matrix, 8, 3, and 5 and 2. The dimension of this matrix is equal to 2. Why? Here, numbers of the rows is equal to 2, numbers of the column is equal to 2. Now, inverse can be represented as A inverse. Okay, how to find out the inverse for the two-dimensional matrix? So, it consists 3 to 4 stages. First of all, find out the determinant of this matrix. This is the first step. Second step, change the position of the diagonal elements. Change the position of the diagonal elements. Third step, change the sign of the other than diagonal elements. And last, fourth stage is to divide each and every element of the matrix by determinant of this matrix. That is the inverse for the two-dimensional matrix. Okay, so dear students, it is it is different from the three-dimensional matrix. So first of all, A inverse is equal to, first step is to find out the determinant of this matrix. So determinant of this matrix is equal to combination of diagonal elements. It means 8 to the 16 minus 5 is a 15 is equal to 1. So determinant of this matrix is equal to 1. This is the first step. Now what is the second step? Second step is to change the position of the diagonal elements. So these are the two diagonal elements, 8 and 2. So we have to change the position of the diagonal elements. Third step, change the position, change the sign of other than diagonal elements. So 3 and 5, instead of 5 and 3, it should be minus 3 and minus 5. And last step, divide each element of the matrix by determinant of this matrix. So here determinant is 1. So this can be represented as 2 by 1, minus 3 by 1, minus 5 by 1, 8 by 1. So is equal to 2, minus 3, minus 5, and 8. So this is the inverse for the two-dimensional matrix. So dear students, inverse for the two-dimensional matrix comprises of 4 stages. First step is to find out the determinant of this matrix. Second step, change the position of the diagonal elements. Third step, change the sign of other than diagonal elements and divide each element of the matrix by determinant of this matrix. So this is the resultant matrix for the two-dimensional matrix. Now, in case of the three-dimensional matrix, inverse for the three-dimensional matrix is equal to adjacent A divided by determinant of this matrix. So this is the inverse for the three-dimensional matrix. Now, how to find out the inverse for the three-dimensional matrix? So dear students, exam point of view, inverse for the two-dimensional matrix and three-dimensional matrix, these are the most important. So A is equal to, suppose 143, 210, and 132. Now find out the inverse of the three-dimensional matrix. Okay, we already mentioned that adjacent A divided by determinant of this matrix. Now in case of, we know that determinant of this matrix is equal to 1. This is three-dimensional matrix. It means 1 and then 1 0 3 2 minus 4 2 0 1 2 plus 3 2 1 1 3. is equal to 1. This is two-dimensional matrix. 2 minus 0 minus 4, 4 minus 0 plus 3, 6 minus 1 is equal to 2 minus 16 plus 15 is equal to 1. So determinant of this three-dimensional matrix is equal to 1. Determinant of this matrix is equal to 1. Now, to find out the values of adjacent A, we have to find out the values of C11, C12, C13, C21, C22, C23, C31, C32, and C33. Now, how to find out that values? C11 is equal to minus 1 raised to n plus n. It means this is the value for first row and first column, and remainings are. Okay, suppose this one is the first element of the first row and first column, so remainings are 1 0 3 2. Okay, is equal to minus 1. This is the element of the first row and first column. It means 1 plus 1, and 1 0 3 2 is equal to minus 1 raised to 2, and this value 2 minus 0 is equal to minus 1 raised to 2 is equal to plus 1 and 2. So the value for C11 is equal to plus 2. Similarly, if you go for this C12 is equal to minus 1, 1 plus 2. C12. So remainings are 2 0 1 2. 2 0 and 1 2. These are the remaining values. Is equal to minus 1 raised to 3, 4 minus 0. Minus 1 raised to 3 is equal to minus 1, and 4 is equal to minus 4. So the value for C12 is equal to minus 4. So next one is C13. C13, it means first row and third column. First row and third column. So remainings are 2 1 1 3 is equal to minus 1 raised to 4. 6 minus 1 is equal to plus 5. Why? Minus 1 raised to 4. Minus 1 raised to 4 is equal to plus 1. 6 minus 1 is equal to 5. So the value for C13 is equal to plus 5. Similarly, if you go for the C21, it means 2 plus 1. This is the element of the second row and first column. So remainings are second row, first column, 4 3 and 3 2. 4 3 and 3 2 is equal to minus 1. Minus 1 raised to 3 is equal to minus 1. Combination of diagonal elements 4 to 8 and 3 3s are 9 is equal to minus 1 is equal to plus 1. So the values for C21 is equal to 1. Similarly, if you go for the C22, this is the C22. It means second row, element of the second row and second column. Second row and second columns. So remainings are 1 3 1 2 is equal to minus 1 raised to 4. 2 minus 3 is equal to minus 1. Why? Minus 1 raised to 4 is equal to plus 1, and minus 1 is equal to minus 1. So the value for C22 is equal to minus 1. Similarly, if you go for the C23, C23, remainings are 1 4 1 3 is equal to minus 1 raised to 5 3 minus 4 is equal to minus 1 minus 1. So value for C23 is equal to plus 1. C31, it means element of the third row first column. So remainings are 4 3 1 0 is equal to minus 1 is to 4 0 minus 3. 0 minus 3 is equal to minus 3. So the value for C31 is equal to minus 3. C32. C32, it means, so remainings are 1 3 and 2 0 is equal to minus 1 raised to 3 plus 2 5 0 minus 6 is equal to minus minus plus 6. So the values for C32 is equal to plus 6. Last value C33. C33, third column, so remainings are 1 4 2 1 minus 1 raised to 6 1 minus 8. So answer is plus 1 and minus 7. So C33 is equal to minus 7. Okay. Now we can put this value in this matrix. A is equal to value for C112, C12 minus 4, C13 plus 5, C211 minus 1, 1, minus 3, 6, minus 7. So these are the values for C112, C113, C33. Now adjacent A is equal to, we can arrange the number of the rows into numbers of the column. So 2 minus 4 5, 1 minus 1 1, minus 3 6, minus 7. Okay, so this is the value for adjacent A, and we know that A inverse is equal to adjacent A divided by determinant of this matrix is equal to 1 by 1. Determinant of this matrix is equal to 1. 2 1 minus 3 minus 4 minus 1 6 5 1 minus 7 is equal to 2 by 1 1 by 1 minus 3 by 1 minus 4 by 1 minus 1 by 1 6 by 1 5 by 1 1 by 1 minus 7 by 1. So is equal to 2 1 minus 3 minus 4 minus 1 6 and 5 1 minus 7. So this is the inverse for the three-dimensional matrix. So exam point of view, this is most important. So how to determine the how to find out the inverse for the three-dimensional matrix? So first of all, we have to find out the determinant of this matrix, and then find out the values of C112, C1, C33, and lastly, we can go for the A inverse is equal to A inverse divided by determinant of this matrix. We are going for the another title is order of group. Order of group can be represented by small h. Now, what is order of a group? Order of a group is equal to numbers of the symmetry elements are present in a molecule. What is order of a group? The numbers of symmetry elements are present in a molecule. As for example, water molecule, it consists E C2 sigma Vx z sigma Vy z. Okay, here number of the symmetry elements 1, 2, 3, and 4. So order of a water molecule is equal to 4. It means H is equal to 4. So what is order of a group? Order of a group is equal to numbers of symmetry elements are present in a molecule. What is order of a group? Order of a group is equal to numbers of symmetry elements are present in a molecule. So H is equal to 4 in case of water molecule. Second molecule is ammonia molecule. Ammonia molecule consists E C3 plus, C3 minus, sigma Va, sigma Vb, and sigma Vc symmetry elements. It means in case of ammonia molecule, numbers of symmetry elements 1, 2, 3, 4, 5, and 6. It means order of a group for ammonia molecule is equal to 6. In case of BF3 molecule or BCl3 molecule, E twice C3, 3C2, sigma H, twice S3, 3 sigma V. So here, numbers of the symmetry elements 1 plus 2 plus 3 plus 3, 6, 7, 9, and 3, 12. It means order of a group for BF3 molecule is equal to 3. So anyhow, order of a group is equal to numbers of symmetry elements are present in a molecule. Classes of operation, or how to find out the class of any group, or we can say operation. Okay, now suppose X, A, B, C, these are the symmetry elements of a particular group, and they satisfy the following conditions. As for example, A, B, C, X, these are the different symmetry elements of a particular group. First condition, A inverse, or we can say X inverse. A into X is equal to A. These are the symmetry elements of a particular group. If you go for the symmetry operation, X inverse, what is X inverse? X inverse is the inverse symmetry operation of X. X inverse means inverse symmetry operation of X. This is again A and this is X. So to give A, it means A is conjugate to itself to form an individual class. Second condition, X inverse A into X is equal to B. It means A and B conjugate to each other to form a combined class. A and B conjugate to each other to form a combined class. And third one, X inverse A into X is equal to B, and X inverse B into X is equal to C. It means A, B, C conjugate to one another to form a combined class. Okay, so we have to go for all the three conjugated properties, and with the help of these conjugated properties we can find out the how many classes of that particular group. Okay, now in case of this one, if x inverse A into x is equal to B. So B is the similarity transformation of A by symmetry operation X. Remember that if x inverse A into x is equal to B, it means B is the similarity transformation of A by symmetry operation X. Okay? First, A, B, C, X. These are the different symmetry elements of a particular group. And if it satisfies x inverse A into x is equal to A, it means A is conjugate to A itself to form an individual class. If x inverse A into x is equal to B, it means A and B conjugate to each other to form a combined class. And third one, x inverse A into x is equal to B, and x inverse B into x is equal to C. It means A, B, C conjugate to one another to form a combined class. It means these are the three different conditions. In this case, x inverse A into x is equal to B. Here, x inverse is the inverse symmetry operation of x by A. B is the similarity transformation of A by symmetry operation X. So, exam point of view, this is most important questions. What is similarity transformations? Find out the order of a group, or order of find out the class of a water molecule or ammonia molecule. So, with the help of these three conjugated properties, we can assign classes of that particular group. So let us start with the first water molecule. Water molecule consists A, C2, sigma Vx sigma Vyz symmetry elements. Okay. Now, in case of water molecule, whenever we talk about the water molecule, it belongs to C2V point group. And if you go for the character table for C2V point group, E, C2, sigma Vx sigma Vyz, A1, A2, B1, B2, 1, 1, 1, 1, 1, 1, minus 1, minus 1, 1, minus 1, 1, minus 1, 1, minus 1, minus 1, 1. This is the character table for C2V point group, or we can say water molecule. Now here, 1, 2, 3, and 4. So in case of ammonia molecule, number of the classes is equal to 1, 2, 3, and 4. So here numbers of the classes is equal to 4. It means 1, 2, 3, and 4. So obviously it should be satisfied the condition number 1. Then and then we can get a 4 class. Okay. So let us start how to find out the class of these symmetry elements or this particular group. So first of all, E inverse E into E. So I think there is no change in the position of the elements by operating E. It means answer should be E. E inverse C2 into E. Okay. If you operate E inverse, there is no change. C2, it means C2. E, there is no change. It means answer is T, C2. Just a minute. We already discussed about the identity. C2 inverse E into C2. Okay, C2 means C21. Okay. C2 inverse. What is C2 or C21? We have to operate, or we have to rotate these molecules along this axis around 180. That is clockwise. That is known as C21 or C2. And it inverse means we have to rotate these molecules along this axis around 180 about anticlockwise. So if you go for the C2 inverse, in case of water molecules, if you rotate either clockwise or anticlockwise, both are the same. So C2 inverse is equal to H2 and H1. So result is nothing but the C2 inverse. And identity, so there is no change. Again, if you go for this C2 C2 or C21, then H1 and H2. So overall result is same. It means it is identity. Similarly, if you go for the sigma V xz inverse, E sigma V xz. Okay, if you operate sigma xz, there is no change in the position of the hydrogens in case of the water molecule. So H1, H2, sigma V xz. So there is no change, but this is sigma xz V xz inverse. It means again there is no change. So if you operate sigma V xz, there is no change in the position of the hydrogens. It means H1 and H2 remains as it is. So is equal to identity. Why identity? This is there is no change by operating sigma V xz inverse. Again no results. Again no results. It means overall is identity. Next, if you go for the sigma V yz inverse, A into sigma V yz is equal to identity. Why identity? If you operate sigma V yz inverse, sigma yz, it means we have to put a mirror over here. So there is a change in the position of hydrogens. It means H2 and H1. And we know that in case of water molecule, if you operate either clockwise or anti-clockwise, both are the same. If you operate sigma V yz or sigma V yz, both are the same. Again, identity. So result will be the same. Again, sigma V yz. So to give the original molecule. So overall result is H1 and H2. It means identity. So if you operate first identity, so there is no change in the position of the elements, or we can say overall result is identity. It means E is conjugate to E itself to form an individual class. So whenever we talk about the character table for C2V point group, E is a separate class. Okay, E is the separate class. So this can satisfy the condition number 1. X inverse A into X is equal to E. It means E is conjugate to E to form a individual class. Now, if you operate C2, then to find out the overall result, C2, 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 C2. Okay, E inverse, there is no change. C2, it means to change E. So overall result is C2 or C21. Both are the same. C2 or C21, both are the same. C2 inverse, H1, H2. C2 inverse, it means 2 and 1. Against C2, again changed H1, H2, and again C2. So H2 to H1. It means overall result is C2 or C2. Clear? Here there is no change, unchanged. Overall result is C2. Sigma yz changes. Overall result is C2. So in case of water molecule, C2 is conjugate to C2 itself to form an individual class. So overall result is C2 or C21. Both are the same. So C2 is conjugate to C2 itself to form an individual class. So whenever we talk about the character table of C2V, C2 is an individual class. Next one is sigma V yz. Sorry, xz. Sigma V xz. Sigma V xz. Sigma V xz. E inverse sigma V xz E. Answer is sigma V xz. There is no change. C2 inverse means changes, unchanged, changes. Again sigma V xz. Similarly, sigma V xz. Similarly, sigma V xz. So overall result is sigma V xz. So sigma V xz is conjugate to sigma V xz itself to form an individual class. So in case of sigma V xz as an individual class, And lastly, if you go for the sigma vyz, E inverse sigma yz, E is equal to sigma vyz, C2 inverse sigma vyz, C2 is equal to sigma vyz, xz sigma yz, xz is equal to yz. So overall result is sigma yz. So in case of water molecule, numbers of the classes is equal to 4. Why? E is conjugate to itself to form an individual class. C2 is conjugate to itself to form an individual class. Sigma Vxz conjugate to itself to form an individual class. And sigma Vyz conjugate to itself to form an individual class. So dear students, water molecule consists 4 symmetry operation and numbers of the classes is equal to 4. Second example is ammonia molecule. Ammonia molecule consists E C3 plus or C31, C3 minus or C32, sigma Va, sigma Vb, and sigma Vc. So water molecule, ammonia molecule consists 6 symmetry elements and number of the classes is equal to 3. So whenever we talk about the character table for ammonia molecule, E twice C3 thrice sigma V, A1, A2, E, 1, 1, 1, 1, 1 minus 1, 2 minus 1, 0. So in this case, E is conjugate to itself to form an individual class. C3 plus C3 minus conjugate to each other to form a combined class, and sigma Va, sigma Vb, sigma Vc conjugate to one another to form a combined class. It means in case of ammonia molecules, the numbers of the classes is equal to 1, 2, and 3. Okay, ammonia molecule consists 4 symmetry elements and numbers of the classes is equal to also 4. And in case of the ammonia molecule consists 6 symmetry elements and numbers of the classes is equal to 3. Now, first of all, if we operate identity symmetry operations, E inverse E into E is equal to C3 plus inverse E into C3 plus, C3 minus inverse E into C3 minus, sigma Va E into sigma VE inverse is equal to sigma VB inverse E into sigma V is equal to sigma VC E into sigma VC. Okay, so according to conjugate properties, E inverse E into E is equal to E. Okay, now in case of the ammonia molecule, suppose 1, 2, and 3. C3 plus, it means one time clockwise rotation. 1, 2, and 3. One time clockwise rotation is equal to C3 plus. C3 minus means one time anti-clockwise rotation. But this is C3 plus inverse. Okay. So we have to go for the one time anti-clockwise rotation. So 1, 2, and 3. This is C3 plus inverse. Again, identity. 2, 3, and 1. And again C3 plus. So overall result is 1, 2, and 3. So there is no change in the original molecule, position of the original molecules of the ammonia. So overall result is identity. This is C3 minus inverse. C3 minus, it means one time anti-clockwise rotation, and C3 minus inverse, it means one time clockwise rotation. So overall result is equal to identity. Now sigma Va inverse is equal to sigma Va. Why sigma Va? If we put a mirror over here, sigma H on H1, so there is a change in the position of the hydrogen 2 and hydrogen 3. Okay, so if we go for the sigma Va inverse. Sigma Va inverse means we have to put a mirror over here on the hydrogen. So to change the position of the 2 and 3, again identity 2 and 3 and 1, again sigma Va. Sigma Va and sigma Va inverse both are the same. Now put a mirror over here to give 3, 2 and 1. So there is no change in the position of the hydrogen. So overall result is equal to identity, identity, identity. It means overall result is identity. So in case of ammonia molecule, E is conjugate to itself to form a individual class, or we can say it satisfied the condition number conjugate properties number 1. Now if you go for the C3 plus, E inverse C3 plus E is equal to C3 plus. C3 plus inverse C3 plus, it is nullified, C3 plus. So overall result is C3 plus. C3 minus inverse, it means C3 plus, C3 minus, C3 minus, C3 minus. Now this is important now. C3 sigma Va inverse, sigma Va inverse sigma Va inverse, it means if you put a mirror over here to change the position of hydrogen 2 and hydrogen 3, next one C3 plus. C3 plus, it means 1, 3 and 2, one time clockwise rotation. Now in case of ammonia molecule, we have to remember that if we operate rotational axis of symmetry and follow by the reflection, now sigma Va, then we have to follow the position before the rotational axis. In case of ammonia molecule, we have to remember that if we rotate rotations C3 plus and followed by the sigma Va, so we have to follow the sigma Va before the position of C3 plus. So in this case, suppose sigma Va, it corresponds to hydrogen 1, but what is the position of hydrogen 1? This is the position of hydrogen 1. It means we have to put a mirror over here. So 2 remains as it is, and 3 and 1 interchange. Repeat again. In case of ammonia molecule, we have to remember that by operating rotational axis of symmetry C3 plus followed by reflection axis of symmetry. So before reflection, we have to follow the before the position of rotational axis of symmetry. Suppose sigma Va, it corresponds to hydrogen 1. So this is the position of hydrogen 1. So we have to put a mirror over here on hydrogen 2. So this is the resultant. So in this one, so this is nothing but the C3 minus. Okay. Similarly, if we go for the sigma Vb, sigma Vb inverse, it means 1 and 3 are interchange. C3 plus, it means 2, 1, 3. Sigma Vb, now sigma Vb, it means this is hydrogen 2. So we have to put a mirror on the hydrogen 3, 1 and 2 interchange. So this is nothing but the C3 minus. So similarly, C3 sigma Vc, one and 2 interchange. Now C3 plus, it means 1, 3 and 2. Sigma Vc, it means this is the position of sigma V3. So we have to put a mirror over hydrogen 1. So 3 and 2 are interchanged. So overall result is C3 minus. Okay. So in this case, C3 plus and C3 minus are conjugate to each other, C3 plus or C3 minus. It means C3 plus and C3 minus conjugate to each other to form a combined class. So whenever we talk about this C3 plus and C3 minus, both are in the same class. So the second class of the ammonia molecule is equal to C3 plus and C3 minus. Similarly, if you operate C3 minus, to give C3 minus, C3 minus, C3 plus, now in case of sigma V1 inverse, 1, 2 and 3, sigma VA inverse, 1, 2 and 3 interchange, then C3 minus. C3 minus, it means one time anti-clockwise rotation, 3, 1 and 2. Then sigma VA. This is rotation followed by the reflection. It means this is the position number 1. This is the position number 1. Sigma VA, which corresponds to hydrogen 1. We have to put a mirror over here, 3, 1 and 2. So after all, this is nothing but the C3 plus. So C3 plus, C3 plus, C3 plus means overall result is equal to C3 plus, either C3 plus or C3 minus, means C3 plus and C3 minus conjugate to each other to form a combined class. Now if you go for the sigma VA, sigma VB, sigma VC, sigma VA, sigma VA, sigma VA, sigma VA, sigma VA. If you operate E inverse sigma VA E, result is sigma VA. Now in this case, if you operate C3 plus, so to give 1, 2 and 3, sigma VA, sigma VA, it means this is rotation followed by the reflection. It means we have to follow the position of the hydrogen before rotation. 1, it means this hydrogen, means hydrogen 3 remains as it is. There is no change in the position of the hydrogen 3. 1 and 2 are interchanged. Then followed by this C3 plus. 3, 2 and 1. So compare this and this. So there is no change in the position of hydrogen 1. So this is sigma VE. Similarly, C3, just a minute. It should be C3 minus inverse. I think that will be the different position. This is C3 plus inverse. This is C3 plus inverse. It means we have to rotate anti-clockwise. 1, 3 and 2. Then sigma VA. Sigma VA means we have to put a mirror over here. So the position of hydrogen 2 remains as it is. 1 and 3 are interchanged. Again C3 plus. It means 1, 2 and 3. So overall result is the position sigma VB. Now if you operate C3 minus inverse, C3 minus inverse, it means one time clockwise rotation, 1, 2 and 3. Then sigma VA. Sigma VA means we have to put a mirror over here, so there is no change in the position of hydrogen 3. 2 and 1 are interchanged, and if you operate anti-clockwise, so 1, 2 and 3. So compare this and this. So there is no change in the position of sigma VC. So overall result is A sigma VA, sigma VB, sigma VC. Here sigma VA, sigma VB, and just a minute, sigma VA. Now what will happen? Sigma VB inverse, sigma VA. sigma va inverse. It means 2 and 3 are interchanged, one remains as it is. Again sigma, just a minute, sigma vb inverse. Sigma vb inverse, it means there is no change in the position of hydrogen 2, 1 and 3 are interchanged. Then sigma va, 3 and 2, and again sigma vb. Then what will happen? 2 remains as it is, 1 and 3 interchange. So here, this is nothing but the sigma Vc, and this is sigma Vb. So overall results may be sigma Va, sigma Vb, or sigma Vc. That means sigma Va, sigma Vb, sigma Vc conjugate to another to form a combined class. So whenever we talk about the class for the reflection axis of symmetry, sigma Va, sigma Vb, sigma Vc, they belongs into same class. It means ammonia molecule consists three class 1, 2, and 3. Now similarly, if you operate sigma Vb, so overall results may be sigma Va, sigma Vb, or sigma Vc. And similarly, if you operate sigma Vc to give sigma Va or sigma Vb or sigma Vc, means sigma Va, sigma Vb, sigma Vc conjugate to one another to form a combined class. So ammonia molecule consists three class, and water molecule consists total four classes. So dear students, this is the how to find out the order of group as well as how to find out the classes of a group. Okay, so with the help of the three conjugated properties, we can assign the class of that particular representations. So I think this is the enough for today's discussion. So dear students, we will meet on tomorrow. So madam will inform you. So thank you very much, Kuspo madam,
Thank you,
for
sir.
the
Thank,
opportunity, and thank you dear students.
thank you, sir, for your wonderful session. We all learnt a lot from your session today. And dear participants, we will be back soon with upcoming session of Paresh sir. Okay, thank you everyone. Have a nice day. Thank you, sir.
Thank you, thank you, thank you madam.